Describing data using numerical measures, descriptive statistics. Can you still remember what descriptive statistics? I just roughly go through this now, right? So it's just a step where we try to describe our sample. You have collected a sample and you try to understand your sample and you try to describe your sample, some of the characteristics that you have. For example, what is the average, what is the highest value, what is the lowest value, and what is the spread of all these numbers. Okay, so these are all the description of the sample that you have. So we split the data into a few sections here. The first section talks about the center, right? So if you take note of the mean, median, and the mode in the first outcome here, the very first item is about the center of a set of data. For statistics, we have three centers. Second one, we talks about the spread. We have range, interquartile range, variance, and standard deviation. These are all the spread of the data. Now, why do we need to look at both is if we have a set of data, and this set of data is has the same average as another set of data. Does it mean they are exactly the same? May not. So what is the difference between these two sets of data? It is a spread that is different. Yeah, the data may have the same average but different spread. Right. So the third one is how do we actually make use of the first item, the center, and the second item, which is the spread, and combine into one rule. We call that empirical rule. I explained these words just now. Parameter are the measures that you calculated from the entire population. For example, population average. So population is entire population. So no matter how you calculate it, it is always the same average. So as long as the population does not change, the value of the parameter will not change. But when we take something from the sample, okay, so when you have a big population, then you take something from there, is the sample, right? When you have the sample, you may have 30 numbers only, where this one you have 30,000 number. This is the population. Okay. So you see, when you take sample, you may not take always the same sample. So the first person may take the 30, take another 30, and you go and sample again. You may not have exactly the same sample. So a measure computed from a sample is selected from population. All depends on which sample you select. Okay. So the value of your average, for example, all depends on which sample you select. So one person will select this sample and you got an average. Another person sample 30 from this population again may not get the same average because the 30 is not exactly the same 30. So now we're going to look at some of the measurements I noted to you just now. You have the center. The first three are the centers. The last one is the location. Okay, location. In statistics, we have three centers. The first center is called the mean. The mean is just average in your daily word. Yeah. So if you look at the way you say average, that is the technical word mean in statistics. What you need to know today is how do we actually interpret the symbols here? When you calculate average, if you want to calculate average for 5 numbers, what do you do? I'll show you this one first. You want to calculate the average for these 10 numbers. What do? You're going to add them up together, right? And divide by 10. So you say that, okay, I get 30. And divide by 10, I get a 3 as the average. So the average of these numbers are 3. But you express it in symbol form so that you don't need to write what plus what plus what. In this way, you just need to use a symbol called sum. This is the sum. You sum up all the x. This is x is the data. This is called x number 1. This is called X number 1. This is called X number 2. And so forth. Okay, you sum up all the X, that will give you the summation of the X. That will be the top number to here. N, what is the N? N is the number of data points you have. You have how many numbers? 10. You just put 10. N is the same N you see last lesson. The symbol you see in statistic will not change. It will always be the same. And how to denote that this is the average of the sample? The mean is denoted by this symbol. This symbol is called X. Then with a bar on top, right? With a line on top, we call that bar. X bar, B-A-R. Okay, X bar, B-A-R. Then, since we have a population, and we take something out, which is called a sample, then we should have two groups of mean. One group is called the sample mean, the other one is called the population mean. Right? How do we calculate sample mean and population mean? Is actually the same way, but in notation wise, they are different. Yeah. So for example, the n, if you only have 30 numbers here, so the small n is 30. But if you have 30,000 here, then the capital N is 30,000. This is not a typo error. 30,000 is the population size, so it is capital N. And for sample mean, you use X bar. For population mean, you're going to use a Greek letter. This Greek letter is read as mu. Is read as mu. Okay, right. So you notice that in population formula, you will see capital letters. You will see Greek letters. If you see any Greek letters or capital letter in a formula, that formula belongs to the population. Now, that capital letter, ignore the X. Yeah, some books will put X as capital letter as well, but except X, the rest will be considered capital. You see capital letter, it belongs to the population. That is mean. The next average that you see, the next center or average you see in statistics is called median. Median is simpler in terms of calculation. What you do is, let me show you a number first. Let's say this is your data. You arrange your data into sequential order, the smallest then the highest, then you have 5 numbers. 1, 2, 3, 4, 5. Then you ask yourself, which number is right in the middle? Number 3. So median is 3. Okay, so if median is 3, half of the data will be below this, half of the data will be above this. Okay, right, so the next one, 1, 2, 3, and the next number is 10. How many numbers you have? It's still 5. So which is the number right in the middle? It's still the third one, right? So the median is still 3. Yeah, it doesn't matter if you have a very big number, huge number here, but median is the number right in the middle of the data set. You have 1, 2, 3, 4, 5 numbers. The middle is still the third number. Okay, so the median is not affected by extreme values. This is the extreme value in this data set because every number is so small. This is a bit bigger, so much bigger, right? If you calculate the mean, then you find that the mean is also 3. So the mean here is also 3 if you take out your calculator and calculate, right? But the mean here will be different already. 10 plus 4 plus 3 plus 2 plus 1, that will give you 20. It will be 20 over 5 numbers, then you get a 4. Okay, so you see the mean is affected, but the median is very stable. It will not be affected by extreme values. Okay, now you look at this. You have how many numbers? 13 numbers altogether. If you want to know which number is right in the middle, first of all, you have to arrange from the smallest to the highest first. Then you can just use a very simple way. 1, 2, 3, 4, 5. Okay, now it's 1, 2, 3, 4, 5. Then you continue. Okay, I continue 1 and 2. So this is the middle, right? So this is the median. This is one way. Okay, how about this? 1, 2, 3. 1, 2, 3. The middle is 2. Which is the middle? Right in the middle. So it has to be the average of these two numbers. Okay, now I'm going to show you the other way of finding the median using a formula. Why do you need to know this formula? Because we need to find location later. We need to use this formula in a later part. So that's why we need to know this formula. Now this formula says the rule is here. Yeah, this is a formula called the median index, half n. And this is a I, right? So this is a rule. We are going to look at the example, then we come back here. The rule says you're going to have I equals to half n. Okay, n. N is 13. N is the number of data points you have. So there are 13 numbers. You get 6.5. So if you look at this, you get 1, 2, 3, 4, 5, 6, 7. This is not 6.5, right? So the rule says if you use this formula, if you don't get a round number here, if this is not a round number, then round to the next round number, which is 7. Next round number is 7. So the median is this. This is the median. Okay, the figure is 12, not 7, yeah? The number is 12. Then how about this one? This is 1, 2, 3, 4, and 5. So this is 4, and this is 5, right? So the median is right in the 4 and 5, but when you use the calculate this formula to calculate, you get half n returns a 4 to you. A 4, 12. 12 is not a median. So we know that 12 is not a median. So the rule of this formula says if you get a round number for this, then you have to take the next number also. This 4 comes from this 4. Then you have to take the next number. Okay, you take the fourth number and the fifth number, and you find the average. Yeah, the fourth and the fifth, and you find the average. So average is 13. So no matter which method you use, you get the same answer. Yeah? You use a cancellation method or use a formula, you get the same answer. So if it's not an integer, integer means whole number. Integer means whole number. Round up to the next higher integer. Yeah, the next number. Yeah, just regard the highest. Then if it's an integer, it's a whole number, then you have to get the average of the one that you gotten and plus 1. Okay, if you get 4, then you need to take the fourth and the fifth to find the average. Okay, this is how you work out this median. Now the next one is the easiest of all, mode. Mode is just the value in a data set that occurs most frequently in your data. So you don't care whether it's the biggest number or smallest number or medium number or right in the middle or whatever. It's not affected by extreme values. Right. You can use for more useful is you can use for qualitative. Okay, more useful for qualitative data. There may be no mode, one mode or two modes or many modes in a data set. So for example, you look at the first data array 1. Which number occurs most? Which of these numbers appear most compared to the rest? Seems that none, because everyone just appear only once. Yeah, every number only appear once. So we can say that this data set has no mode because all values only appear once. Look at data set array set 2, 449, blah, blah, blah. There's only one number appear more than the rest, which is number 4. So the 4 is called the mode. The mode is 4. There are only one mode inside here, so we call that uni. Uni means only one. If you have a look at data number 3, 4499 and the rest, then you find that there are 2, 4, and 9. So 4 and 9 are both modes. So there are 2 modes. We call that bimodal. Yeah, remember the graph where you have 2 highest point, then you call that graph bimodal. It's the same word. So I just want to let you aware that mode is more suitable for qualitative data. Why? Mode supposed to center, but you may end up telling someone that there's no mode in the data. It's just a center, right? But it says no mode. So mode is not so suitable for numbers. It can give you an idea, but it's not the best way to express the center. You either use the mean or you use the median. Right, mode is more useful for qualitative data. What if we already group the numbers into a class like that? 10 by under 20, 20 to under 30, and so forth. Where's the mode? You lost a number. Just to show you, the bottom is the one that I use to put in all the numbers inside this table. Right. So if you have the original number, you find that the mode is 24 and also 27. There are 2 modes here. But once you have grouped this data into a frequency distribution, you sort of like lost the original number. You don't know what is the number inside each of these class. Doesn't matter. You just need to pick up the class which has the highest frequency, and that is the model class. So the model class is just 20, but under 30. This class is called model class. Okay, so this modes not necessarily will fall inside this. Not necessary, but I'll just show you that this is the original. We lost this. We can only know the model class from here. Right, so just a summary of the 3 items that we just mentioned. All are centers. Yeah, they are all centers. So what you need to understand is mean is sensitive to extreme values. Extreme values means very big values or very small values in your data set. And just now I show you the median is not so sensitive. It's so stable right in the middle of the whole data set. Right. So in other words, if you have a data which shows you that you know that there will be extreme values in your data set, then the best center that you would like to tell people about the data is the median. Okay, I repeat, if you know that your data set has extreme values, then the best number that you would like to report as center of your data will be median, because mean will be affected by extreme values. It's not so accurate anymore. Mode is not so useful for numbers because you may have multiple, or you may even have none, no mode. Okay, so mean is generally used if there's no extreme values in your data set. Now just take note of another technical word. The technical word for extreme values is outliers. Outliers. It's like a stranger in the in your data set. Okay. If there are extreme values, then median is often used, since the median is not sensitive to extreme values. Right. Mode is good for determining values that are more likely to occur. So it's more not so suitable for numbers. Okay, it's used for other things, qualitative. Right. So we'll stop here for a while. We take a break for 20 minutes, then we continue.